Now we're going to start discussing K-means clustering. So what is this? K-means clustering is a way that we can categorize data that doesn't even have any labels to it. Data that doesn't have any labels is considered unsupervised learning. So this is a methodology that can sort our data into various bins or clusters, and therefore it's really good at categorizing data based on multivariate analysis that is not even labeled yet. So we place k centroids randomly, and that's chosen by the user. So you get to choose how many categories you'd like to make. Obviously, one would not be very meaningful, but anything larger than one, so two, three, four, five, six, we can get into these bins using geometric distance. We assign each point to a nearest centroid, recalculate centroid position, and then we repeat until centroids stop moving, and then we've got our clusters that are finalized. So we randomly put these locations, we measure the distances to each of the points, and then we move the centroids until those distances kind of stabilize, and then we have our categorizations based on the variables that we chose and the number of bins that we decided to look at. So unsupervised learning, no labeled target column needed, discovers natural groupings from feature similarity alone. It is distance based, so it uses Euclidean distance, which is the regular distance formula that we've come to know and love in many dimensions, depending on how many variables we're considering. Points closest to a centroid get assigned to that cluster, so that's how they're categorized. You choose the K as a user. Analyst specifies number of clusters. Use elbow method or silhouette score to find optimal K. And then the algorithm repeats until centroid positions stabilize, usually converges in 10 to 100 iterations. So what business requests or what business use cases exists for K-means clustering? So here's example number one. Who are our distinct customer types so we can personalize messaging, right? Classic customer segmentation. K-means groups customers by purchase behavior, demographics, or engagement without pre-labeling. How we decide to categorize these customer bases is strictly up to the analyst, but there's usually a tiered hierarchy system, right? We have our preferred customers, or they have silver or platinum or diamond membership, and so you've experienced these before in the real world. Can we group our 300 store locations into performance tiers? So store clustering by revenue or traffic and region. This reveals hidden underperformers in high potential locations. So it's important to look at things how they organically sort themselves. And so if we have a lot of variables that might be desirable for a store, we can use those to see which stores are overperforming where the I guess the precursory glance at the data may not make it so easy. Sometimes when we're looking at just profit, it becomes very easy to evaluate where a store belongs based on how high the profit number is. But if we're looking at many things like revenue, traffic, and region, it becomes a little bit more confusing, and this is where K-means clustering can help. Which product families should we bundle in promotions? So this is an affinity clustering. Group SKUs by co-purchase patterns, price sensitivity, and margin to drive bundle strategy. So co-purchase patterns, when we're shopping through Amazon and we look at things, there's always people that bought this also bought this as well. So they're trying to link these products together. So if I buy a uh, a camera, or let's say if I buy a camera, it's probably going to try to sell me batteries that fit the camera as well, and maybe even a lens that goes with it, or a carrying bag. And so we start getting this understanding of how we bundle things, and K-means clustering is useful for that as well. Are there distinct employee engagement profiles in our workforce? So HR segmentation, this clusters employees by survey responses to identify flight risks, high performers, and development needs. So maybe you want to look at a more creative way on how to engage with your workforce in order to target areas that you would like to improve. And K-means clustering can also help with that. How do we segment our supplier base for risk management? Supplier profiling by reliability, volume, and geographic risk. Again, all of these are multivariate. enables differentiated contract and contingency strategies. So we're making these groups, these classifications, in order to drive strategy. And what you'll see is a lot of these are very, very similar, right? Uh, who are our distinct customer types? So it's a classification problem. Can we group our 300 store locations? That's a classification problem. Which product family should we bundle in promotions? That's product families or classification. Are there distinct employee engagement profiles in our workforce? These profiles are classifications. How do we segment our supplier base? We're segmenting it into classifications. So maybe it's not very clear exactly what these bins should be named, and then the context of the variables inside of them you can kind of pick. So it isn't always very obvious what the bins are called, but it does sort them into classes. And so what type of data requirements exist for K-means? So we have to have all numeric or encoded features, and they have to standardize them. So we can't have uh, very irregular distributions in the data, and so we want to standardize with z-scores. No target column needed. Again, this isn't trying to predict, or we're taking all of the data together and working to classify it. And it works best with 100 plus rows. So we have less of a volume requirement than we had for gradient. Avoid raw categorical text, so it doesn't work with text data. Highly skewed or heavy outlier data distorts centroids, which is also an issue that we can deal with the z-score. Right? How to evaluate? Okay, so there's the elbow method and the silhouette method. This can help us provide how many bins should exist given the data. And so plot inertia with cluster variance versus K value. The elbow bend shows optimal K. And silhouette score ranges from 0 or -1 to +1. Values for greater than 0.5 are well separated clusters and the best objective metric. So we want values greater than 0.5 to have that well separated clusters. If we have it less than this, then the clusters are kind of blending together. Business validation. Do the clusters make business sense? Can you name them? Are they actionable? And so here's something that is a good step for a business analyst. We can do all of these models, but we have to be able to interpret them and then use them. And sort of that business validation step is naming good categories. Cluster size balance. Avoid k-means producing one giant cluster and then tiny singletons. That signals bad k-choice. So if we have a lot of clusters that only have one element or none, and then another that has most of the data, obviously we're not doing a very good job there. So walking through some examples, so we have some setups and then some outputs, and we can learn how to interpret those results. And so these slides are made so that you can interpret what the output means and then draw some meaningful conclusions. So example one, we are a coffee chain customer segmentation. So we're categorizing, we're classifying customers. We have 800 loyalty members, and the variables are monthly visits, average spend, mobile app usage, and drink type. And so we scaled with the z-score and then case selected via the elbow method. And so via the elbow method, which I'm not we'll go into whenever we have the visualization and talk about that. The elbow method recommended we have 4 clusters. The silhouette is greater than 0.5, so we're having that good distance separation, so we're not blending our clusters together. Daily commuters, which is high frequency, low spend, and then weekend socializers, which is low frequency, high spend. So what we're seeing in the clusters is that these two variables, frequency is high, spend is low, is a very good cluster that's established. And then cluster B is low frequency, high spend, so kind of the opposite of these, right? And they called them daily commuters. The business analyst took these and said, if I've somebody that is here all the time but spends a very low amount of money, that sounds like somebody that's buying a regular coffee every day, maybe in the morning on the way to work or on the way back, or maybe their third shift and they're buying late. But we're seeing high frequency, low spend. And then the weekend socializers, those that may gather at a coffee shop and get food and a drink or buy each other or buy the entire table drinks. So we're getting this very low frequency, maybe only once a week. But then we get really high spend because they're getting a lot of things because they're staying there a long time. So they're socializing. They're not just passing through and grabbing a coffee. Right. Cluster C, And cluster D, we have power users, lapsed members, re-engagement campaigns. So these are some other things we didn't go. They didn't go into the variables here, but these are some very useful insights, and then they labeled them so that we could get some understanding and context about how they're labeled. Example number two, retail store performance tiers. Again, we get fitting people into performance tiers. Or fitting stores actually. 120 store locations, right? So we are over 100, so we met our data requirement. We're looking at revenue and over square foot, foot traffic, NPS score. I'm not really sure what that is, and inventory turnover, and then all the features are normalized. So we've treated all the data, right? Um, K clusters chosen was 3 here. The silhouette is close to 5.5, but it's over it. So we're getting, again, that good separation between the clusters. They're not overlapping. We want this above 0.5, right? This is a user decision. So if we raised this up, this silhouette's going to go lower until it gets too low, right? We don't want it too high either. We want to get it as close to 0.5 as we can, while not going under, right? And so that's how we determine our K clusters. Tier one, so we're going to call that's what they called them, tiers apparently. 22 stores fit in this cluster, and they are high revenue, high NPS flagships. So these are very good performing stores. They are our flagships. Tier two, 68 stores, average performers, or obviously this is going to be a lot more than the 22 stores. So we're getting average performers, and then tier three is 30. These are underperformers, and so we're looking at those candidates for remodeling or closing. B2B supplier risk profiling. Here we have 200 suppliers, the last example. 200 suppliers, which is more than 100, so it meets the data requirements. Uh, Features on-time percent, defect rate, single source risk, and geographic concentration. Outliers are removed. And so this is a methodology if we have severe outlier issues. If it's appropriate on the analytics side to remove those outliers, which can sometimes happen, then we can start using K-means with a little bit more strength. Results: 3 clusters, and the silhouette's 0.54. Again, closest to 0.5 without going under. So we have the silhouette of 0.54, meaning we're having that good separation of the clusters, and we're not overlapping or getting too close. Low risk, there's 110 suppliers. These diversify orders are here. Medium risk is 60, and then high risk is 30. So we have to develop alternatives, single source from conflict regions. Here we're having high risks. These are the things that we prioritize, right? And so this is where K-means can use classification to, again, develop strategies. And that's what we're doing here. Every single time we talk about business analytics, we're trying to make models that help us get to that strategic building that's data driven or AI driven or machine learning driven. Okay, I think we're going back.